And we are live. Hello, everyone. Um, let's just wait for a few more people to join so that we can start the first Talk to an Expert. How are you, Krzysztof?
I'm really great. Thank you, Britt. How are you?
I'm good, thank you. Excited for today.
Yes, me too. Great to be here.
So, I guess we'll just dive in straight away. Welcome everyone. My name is Britt and I'm the marketing manager of Eatron Technologies. We're very excited that you're here for our very first Talk to an Expert. This new event that we're starting will be going live every last Thursday of the month around the same time as this. So keep your agendas open. Please bear in mind it's our first live event, so if there's a few tweaks, just bear with us. So for those who don't know us, Eatron is an international technology company dedicated to making software-defined vehicles a reality for OEMs worldwide. We develop and license intelligent product-ready software solutions for the automotive industry and mobility. This innovative platform, which spans from the edge to the cloud, enables OEMs and Tier 1s to rapidly integrate Etron's offerings for serial production. So, our house rules, if you have any questions that come into your head, please pop them in the chat and Krzysztof, will be answering them at the end. So our very first expert to join us is Krzysztof, the BMS product manager. So Krzysztof, can you please introduce yourself?
Yes, thank you, Britt. Thank you for introducing the session, and hello to everybody. Good morning, good afternoon, and or good evening, wherever you're checking in from. It's really great to be here, and I'm excited about joining this event as a panelist. And I hope that you'll also get a lot of value from joining at your end. Few words about me. I'm the BMS product manager here at Eatron Technologies, and I've been in the automotive industries for nearly 15 years now. I have a background in controls engineering, and from the early days of my career that started at Jaguar Land Rover, I worked on various battery management systems, starting from a smaller 12-volt lead-acid BMS all the way to leading the team developing high voltage BMS for Jaguar I-Pace. After my time at Jaguar Land Rover, I also led the team developing battery systems for lithium sulfur chemistry. But the main focus of today will be the lithium ion technology and the BMS for that that presently runs our electric vehicles.
Thank you so much. So I'm not an expert and I would love to know a bit more about this topic. So can you please tell me what a standard BMS is?
Yes, really good question, Britt. And as you know, batteries are powering up everything around us these days, from like this phone to like this laptop that I'm using to join this call, to even like powering the whole houses, all the way to to powering our cars, whether it's a pure electric vehicle or a hybrid electric vehicle. Everything has a battery inside it, and batteries, because of their nature, they need to be managed correctly by the by the specialized hardware and software, which we refer to as a battery management system. And that battery management system is designed to accomplish a few very specific objectives. And number one is to actually protect the user of the application the battery is powering up, and number two is to actually protect the pack itself, the battery itself, from any damage, from any abuse. The pack itself, the battery, the chemistry is really expensive still, although the prices came down drastically. But for typical electric vehicle, the pack will constitute approximately a third of the vehicle cost. So the BMS really needs to protect the pack. And because it's such an expensive piece of technology, the BMS really needs to do everything it can to maximize the power and maximize the energy available and usable that can be extracted out of the pack, and do it in a way that also allows the pack to last for as long as possible. Again, because it's such an expensive piece of technology.
So basically, to extract all the juice from the battery.
That's a good way to say it. Yes.
So can you then please tell me why a standard BMS is no longer enough, keeping in mind it's been implemented into so many electric cars?
Yes, that's and that's actually a topic of today conversation, and the reason why this conversation is so timely, because electrification is happening. There is no deny about this. When I first worked on BMSs 10 years ago, it was still debatable. 2030, British government is putting a ban for sale of all internal combustion engines, new internal combustion engines, which means like from there, that's only 8 years from now, every car is going to have a battery, and every battery will have to accomplish this set of objectives, and every car one day will become will have a battery. The BMSs that are out there, they do a really good job at ensuring the safety of the users, and they are protecting the pack fairly well, as long as the pack has been designed and BMS has been designed to follow the rules of strict standards like ISO 26262. And the ones that didn't, you hear some horror stories about batteries catching fire. But as we are moving to this mass adaptation, and we will see an increase in the uptakes of EVs, the performance is becoming more and more of an issue. Why? Because of the cost that we talked about. The users wants the batteries to be as cheap as possible. That puts a lot of pressure on OEMs. The OEMs wants to get as much energy out of the packs, to keep the packs as small as possible. Have the cars which are a competitive product out there, that has the longest possible range, and really that is enabled. That performance of the batteries is enabled by the software and the hardware that manages the pack, and the accuracy that at which it does it. So there is a big focus, and there is a big need on improving the accuracy of the features and functionalities like state of charge estimation. Typically, what we see currently on the road are for the chemistries that most of the EVs are out there, like NMC. There is the accuracy of state of charge is in the range of 3, 4, 5%, depends how good the job that the engineers were able to do. It really needs to be 1%, right? Anything lower than 1% is probably is probably going to be difficult to actually maintain throughout the life of the pack. But let's just concentrate on that difference between 1% and 2% for a conventional vehicle. If if the vehicle has got a pack of 100 kilowatt hours, 1% equals to something like 3 to 4 miles of range. And if we are expanding the window of SOC on both ends for the charge and discharge, that's 4% of useful state of charge window increase, which quickly translates to 16 miles, right thereabouts. And that's something to fight for. That's something to fight for. So accuracy and performance really needs to be as best as possible.
Okay, so about that, if it needs to be as best as possible, how can we solve this problem, and what can we do about it? I'm sure everyone here is curious.
Yes, that's a really good question. There is a lot of scientists and a lot of engineers are working to crack this code, and typically what helps a lot is the advancements that we've seen in the kind of silicon industries, and all the microchips actually available on the market are way more powerful than they were a few years ago, which really allows for the software that runs on this hardware to be even more sophisticated, and which means that the subject of state estimation, which is a controls problem, by the way, could be solved by deploying advanced controls techniques, where there is a a complex algorithm that extracts and tracks the state of the battery. But in order to do this, these control algorithms requires a mathematical engine, which is typically a model, and the key is to actually bring the model to be as accurate as possible, and typically this comes with a lot of understanding of the actual processes that are happening within the cells that then are implemented correctly within the software, and then with the model and the advanced controls, we can achieve the best possible accuracy.
Okay, so you've done your master's in advanced controls and you've been working on BMS quite a long time, I heard in your introduction. So can you please explain a bit more how that goes together in Eatron's battery management system?
Yes, that's a very interesting question. In fact, I expect that we have a lot of students on the call, and to begin with, I really wanted to congratulate you and acknowledge you for choosing this field as your career. There's a real future, and you'll be at the forefront of it when you finish your degrees. But the whole battery management system is a controls problem. The battery needs to be charged properly. That's a controls problem. It needs to be balanced properly. That's a controls problem. The estimation of the state of charge, it's a controls problem. The actual development of the parameters for that model is a controls problem. So that expertise is right at the core of it.
Okay, thank you. And so AI and machine learning are currently very trendy topics, and I was wondering if this is also integrated into the BMS?
Yes. We talked about the big pressure on cost. We talked about the big pressure on the expectations for the batteries to be as cheap as possible. And with this comes the whole topic of warranty, and the BMSs as we see them currently on the market, they are very reactive. And what we mean by this is that they are doing a really good job at solving the safety problem, but there's still to be done. There's still quite a lot to be done in order to balance out the reliability with the software. I mean, the safest electric vehicle is the one that is in the middle of the field, connected to the charger, away from any people, with the contactors open. Perfect, right? But that's not the point, right? We want to move to we're moving to the mass uptake of all the EVs. We want to keep these cars on the road for as long as for as long as possible, which means that the whole diagnostics aspect of battery management system needs to be preventative as much as possible. And and what we mean by this is to actually predict the failure before it actually manifests itself into a stage where the reaction is required, and that that prediction of the fault is done through is a complicated problem, right? How do you do this? So luckily, with with the advancements in the sort of chip technology, we can run some powerful machine learning algorithms for the first time in the history of BMSs that can be designed, can be trained, can be really kind of tuned to pick up these abnormalities and provide this very, very important elements of the diagnostic, which is no longer sort of reactive, but it's actually preventative. Another element where artificial intelligence is really useful for, and that's also going along with the warranty topic, is the prediction of remaining useful life. If if the pack is a third of the cost of the whole vehicle, as a user, I want the pack to last as long as it can. And and if I was to buy a second-hand car, I would actually want to know when the like what am I buying, right? Am I buying a car that will die tomorrow, or am I buying a car that will last me for the 5 years? And typically OEMs have no choice than actually mitigate this risk actually by taking it on themselves, or their own insurers and things like that, by offering an extended warranty period to about 10 years. But there's a lot that could be done to help the cell suppliers, the OEMs, the actual users, if that information was available. And in fact, it's not a secret, but at Eatron we are very, very, very heavily developing this piece of technology as we speak, where we want to solve this problem for the whole industry, where we're really bringing this AI element and the physical models together to accurately predict the remaining useful life of the batteries out there.
So what about data and connectivity? Is that implemented as well?
Yes, the standard BMSs are getting more and more connected, and there is an aspect of like bringing the software updates in, but the BMSs can be smarter than this, and needs to be smarter than this, because the engineers who are doing all the great work to release the software and its parameters, they have a limited data set, and they only can work on the data that are available at the start of production. And therefore, the BMSs really needs to actually get better after production, as opposed to worse after the production. Why? Because there's so much data that could be used to improve it. So with the connectivity and the cloud computing, this very objective can be easily achieved. And this goes with the ethos of actually continuously learning and continuously improving the software after the production. Since these packs are going to be exposed to such a variety of different noise factors, they're going to operate in different atmospheric conditions. They're going to see different levels of abuses. If BMSs can actually talk to each other, right? And that data could be actually extracted, then the software can be either reparameterized to maintain that accuracy that we were talking about throughout the life of the pack, extend the life of these packs, help elevating some of the warranty issues, and many more benefits.
Okay, so you've mentioned something about if BMSs could talk to each other. Maybe crazy question, but can they learn from each other?
Yes, so the aspect of learning is where the cloud kicks in a lot, and the whole concept of having a digital twin actually running and mimicking what's happening on the edge, and feeding that digital twin with the data, and actually bringing all the kind of insights or the outcome back into the application that runs on the edge. So it is very possible. In fact, that's the whole ethos of the software platform that we are developing as part of BMStar.
Okay. Well, thank you so much. I've learned a lot today. Well, for everyone who's watching us, if you haven't wrote a question yet, please start typing up so that Krzysztof can answer them. We've already got a few questions in the chat. Krzysztof, are you ready to answer them?
Yes, and please do, as Bridge said, put the questions in the chat. If I don't manage to cover any questions, we will follow up with the answers offline, but all the questions will be answered. So the first question is from Jason. What makes up most of the cost of BMS, primarily rarity of raw materials, or the research and development of the technology? Really good question. This the cost of raw materials, and in fact the availability of the component, we've seen a strange kind of shift in the last 2 years, as everybody in the automotive industry, but predominantly the cost of the BMS is actually quite a variable element, which really depends on like how many of these units of hardware you need to put for a given pack. So there is a function of the size of the pack and the cost of the BMS. If the pack is an 800 volts, it has simply more cells that needs to be managed and needs to be monitored correctly. So that's that's a big driving factor. In terms of the cost of the actual computing unit, we've seen a big decrease. So that's not a big driving factor. And of course, the R&D, as you pointed out, for anything that is really kind of helping to achieve that top performance, there is going to be we'll see an echo in the actual cost of the software license associated with the whole system cost. But typically the cost of the system is a function of the cost of the size of the pack and the amount of software features that runs in it.
We've also got a question from Paul. How do you assure that you correctly train the machine learning?
Yes, really good question. Thanks, Paul, for this question. It really comes with actually having, first of all, a specialized knowledge in the batteries and doing a very good study in what actually makes the input information that actually makes the carries the information that are needed. And in fact, most of the work happens in the actual data preparation, data selection. When this job is done, the training is somewhat not so difficult. The choice of the actual model and the methodology is going to drive the performance. But if the machine learning model is kind of it's only as is not using the right set of inputs, it's not going to work very well. So it's all in the inputs. Hope that makes sense. Chaitali asks, please, can you help us understand how we understand pack has reached end of life and user communication is done via which software, please? How data is communicated? Is it via algorithm? Very good question, Chaitali. The end of pack is we can actually understand this question through the actual basic information that are available, which is state of health, right? State of health really gives us an information about the pack's age up until now. So it really kind of gives us the information from the past up until now. And the remaining useful life algorithm that I was referring to is actually like from now until the future, until the end of life. So depends what is the interest. Both of these informations could be extracted, and if the solutions that we are developing for remaining useful life has got the cloud extension to it, purely to make it as accurate as possible, and it requires quite a lot of computation. So then this information are either available from the cloud. They can also be extracted from the edge. Yes, the communication part, if I understand the question correctly, is actually closed communication. The cloud communicates back with the edge, and the edge communicates back with the cloud.
We've got a lot of questions coming in, Krzysztof.
Really good. When do you think cloud-connected BMS will be state of the art for every produced EV? Really good question. I think the state of the art in terms of when it's going to be in production, as Eatron, we are aiming for 2023. In terms of when it's going to be deployed for every produced EV, well, it's there already. In terms of Tesla is connected. It's not a brand new concept, but it's what you use it for is actually the most interesting thing. We spoke about some of the use cases, but the trend is to actually have the cars, like connectivity is one of the mega trends. So typically, all the EVs at some point are going to be connected to the cloud, but how the cloud information are going to be used to actually improve the product, it's a variable. Hope that this makes sense. Can BMS share data with DNO, DSO? Anthony, if you could just expand on what DNO and DSO. I'm not sure I understand this, and I'll try to cover this up again. Genchai asks, what is the efficiency contribution of BMS to the overall system efficiency? That's a really good question. If the accuracy of the state of charge or the whole state of SOX, and that constitutes also state of health, state of power, state of energy, could be brought to the 1%, then if I understand correctly the system efficiency questions, then there is only 1% of the usable energy that isn't actually accessed by the system. So the kind of weight increase when going from cell to pack is improved by proportionally, and what we typically see for a really good pack, that efficiency could be in the range of like 30%, maybe a little bit better. So it will be proportional to that.
Krzysztof, Anthony actually answered, and he says distribution network operator for LV visibility and perhaps network loading.
Right. Okay. Makes sense. I see. Okay. I think that's a slightly bigger conversation, whether the BMS can share the data with the distributed network operators or perhaps the network loading. That's going to be very, very much an OEM specific questions. Typically, OEMs are very conservative when it comes to like sharing the data. I think it can be shared in theory, but I think there is a lot of sensitivity topics around these sharing the data sort of issues that basically is going to come down to an OEM. I hope that this answers the question. Cool. The next question is from Shurendrian. Is decentralized BMS suits for high voltage battery packs? I hope that the decentralized means actually the pack and also the unit that is the main control unit and the number of secondary units. Yes, it is still a very suitable architecture for the battery packs for high voltages, 800 volts and above. Typically, the high voltages, the high voltage elements really come down to the need for having to monitor all these cells, and therefore the more effective architecture is to actually use a ASIC that can support more channels, because that actually brings a lot of efficiencies. Aaron,
sorry, I've got a few more questions, so we'll probably go slightly over time. So if you've put a question already in the chat, we'll answer them. And if we don't answer them, then we will send you a direct message with the answer to your question. But if you're willing to stay a bit more, then Krzysztof's more than happy to answer.
Yes, I'm happy to stay, and we'll probably run for another 5 minutes, and then we will take all the questions that I can't answer and follow up with every single one of you. Erin says, "Great initiative. Thank you, thank you."
Thank you.
My question is, do you have any plans of developing fleet level in terms of cost and longevity BMS controls via connected vehicle architecture? As far as I understand, the BMS problems are generally solved at an individual vehicle level, but would be interested to learn if there is if there are fleet level unique problems. Yes, actually, that's a really good question, Iren, and that's actually one of the use cases, because typically the fleet operators are assuming that the electric vehicle is going to actually work the way it needs to work for their given application, and the fleet typically is a very kind of specific usage, and so that whole connected element and actually adaptive element of the BMS allows for the fleet owners to also get an insight, and based on these insights trigger any fleet level improvement. The BMS that Eatron is developing has got a personalization layer to it, which means that every single car or a group of cars could be individually optimized, and with this in mind, it would just refer to a group of cars that operates under a fleet. Hope this answers your question. Charushli Shila asks how important it is that BMS software shall be ISO 26262 compliant. Is it the actual need or just another customer requirement? That's a really good question, and I'm sure there is going to be some controversy to this answer. I know the standard. I've been working with the standard, and I know that the standard is extremely strict. There is a lot of effort to actually implement everything per the requirements from the standard. But I would personally not buy a car that didn't follow the standard to develop an electric a BMS for the electric battery, because there is just so many things that can go wrong. So the customers are asking for it. It's not a sort of must-have standard, but there are countries like Germany where if something do go wrong, the first thing is that is being done when there's an investigation is what type of methodology that was used to actually develop this and prevent this from happening, and that's actually from the industry perspective but the best tool that us engineers have in order to ensure that the software and the whole system is designed to the right level of safety, and it mitigates all the risks that are driven by the nature of the chemistry itself. So it's very important. That's my personal view.
Burak asked, during your description, I kept hearing 1% of error in SOX as a target. As Eatron, do you achieve 1% accuracy with LFP cells?
Really good question, Burak, and I should have also made that reference to the LFP. So really good that you jumped out with this. LFP is somewhat more tricky in chemistry to manage because of the like flat voltage region as the cell is discharging, which really makes it very difficult to estimate the state of charge accurately to that level of accuracy. So at Eatron, we're developing SOX for LFP with the 3% accuracy. The industry is currently at 5, 6, 7. I've heard some numbers recently. NEO actually has shared a very interesting video where they were referring to something like 10% accuracy. I think the overall industry is a little bit better than this, but internally we're developing it to 3%, and we're really getting very good results from it already.
Got 3 more questions left.
I think we can cover it.
Yeah.
Chaitali, thank you for answering previous question. I'm willing to understand which background in studies would be critical in electrical vehicle powertrain and scope for the future, mechanical design versus controls. What holds highest percentage of risk factor in developing EV powertrains? EV powertrain will essentially require skills of electrical engineering, software engineering, mechatronics, mechanics, and in fact, wherever we recruit somebody, and controls, right? Wherever we recruit somebody, that's the kind of field that we are always looking for. Naturally, when you select a field like controls, you will be mostly working on the software elements. If you choose the kind of angle of mechanical design, you will be probably closer working with the actual hardware. But either way are going to be a great choice of a career. This is the future. Rajesh asks, what would be battery pack life in 800 vehicle system? Maybe something like Porsche Taycan. Honestly, that's probably a question for Porsche. From the system voltage point of view, because the currents are lower, the pack is going to be exposed to lower C rates, which means that the cycle life is going to be slightly better. It becomes a standard that 10 years of warranty is something that the users are expecting, which means that the OEMs needs to at least design the pack to last that, so probably 12 years. But it all depends on the actual usage, the operating conditions the pack is operating, the charging scheme, a lot of factors, but 10 years is a good sort of rule of thumb.
And our very last question, the issues of obsolescence of BMS, is it a big deal, and what's the biggest challenge here?
I'm not sure. I'm not sure my English is on this. I don't think I understand the obsolescence of BMS. Can we clarify this one?
Obsolescence is the process of becoming
obsolete,
outdated, and no longer used.
I see. Okay. I believe that as long as the chemistry is the chemistry doesn't behave itself, it will always require a BMS. So when I worked on chemistries like lead acid, there was no real issues around balancing. There was no real issues about charging, because the chemistry doesn't really have these issues inherently. With the move to but for as long as the industry sticks to lithium ion, BMS is always going to be needed. We are yet to see what's going to happen with the solid state. We're yet to see what's going to happen with any upcoming chemistries. I strongly believe that the more with the upcoming technologies, there's only going to be more work to be done on the BMS, and that's what I've experienced when I worked on the lithium sulfur chemistry. There was a lot to do. So I don't think there is such issue at all. That's my personal opinion. But thank you for asking this question.
Well, that was the very last question, Krzysztof. Thank you, everyone who has attended today. We were very excited for today. Make sure you stay tuned for the next one, and we will be doing this every month. So thank you, Krzysztof, as well, for joining and answering all the questions. And you've really enlightened for us today.
Thank you, Brit. Thank you, everybody. I appreciate you all. I hope that you found this session very valuable, and I'm also looking forward to the next session next month, Brit.
Thank you.
Which will be with another expert, possibly, right?
Oh, yeah. Every month it's a new expert.
Great. Thank you, everybody.
Thank you. Bye.
Bye.